Hey everyone, today we're going to be going over LeetCode problem 252, meeting rooms. This is another problem off the Blind 75 list, which is a list of problems commonly asked during technical interviews. In this problem, we are given an array called intervals, and each interval has a start time and an end time. And what we want to do is basically determine whether or not a person could attend all meetings. So we know that a person can attend multiple meetings, and the entirety of these meetings only if these meetings do not overlap or they do not conflict. So we have here an example, example 1, and we have an intervals array with 3 meetings. We have one which starts at time 0 and ends at time 30, another which starts at time 5 and ends at time 10, and a final one which starts at time 15 and ends at time 20. So as we can see, this second meeting starts after the first meeting. It starts at time 5, whereas the first meeting starts at time 0. However, the meeting starts before the prior meeting ends. And so if both of these meetings are going on at the same time, the individual cannot attend both meetings because while he is in the first meeting, the second one begins. And so we must return false because we have conflicting meetings where the intervals overlap. So one thing we could see is that these meetings that are given to us in this specific example are sorted based on start time. Because we see that the first meeting starts at time 0, the second meeting starts at time 5, and the third meeting starts at time 15. And this is kind of a suggestion from LeetCode in order for us to start thinking about how we want to organize our data in order to be able to solve this problem. In fact, we will see that it is actually convenient for us to sort the intervals based on start time. So I've constructed a timeline for this specific example with the 3 intervals, one going from 0 to 30, one from 5 to 10, and the other from 15 to 20. Now what we will do is start with the first meeting, which starts first at time 0. And what we will do is basically compare to see if this meeting ends before the next meeting starts. So we see that this time, the time of the ending of this meeting is 30. And the next meeting starts at time 5. So when going to compare this meeting, its end time, to the beginning time of the next meeting, we see that it ends after the next meeting begins. So this means that the two intervals will overlap, they conflict. And so these meetings go on at the same time, and a person cannot attend both of them, so we must return false. So I have constructed another example for us here in order for us to be able to understand better how this algorithm is going to work. So we have another intervals array, which has 3 intervals, and these intervals are 5, 7, 0, 3, and 3, 4. Now, what we said we wanted to do is, in order to have more of a timeline depiction, is that we want to sort this array based on starting time. So if we resorted this array based on starting time, we would first have the interval which starts at time 0, then the interval which starts at time 4, and finally the interval which starts at time 5. And now we see that this more or like looks like our representation on the timeline below. We have first this interval which starts from 0 and goes to 3, then the interval which goes from 3 to 4, and finally the interval which goes from 5 to 7. Now we want to go along in this sorted array and compare each at a time 2 intervals. So what we're going to do is start with the first interval and see what time this interval ends, when this meeting ends, and go and see if this ends before the next one begins. So this interval ends at time 3, and the next interval starts at time 3. So the meetings do not actually conflict because one ends at the same time that the next begins, so the individual can attend both meetings. After which, we would move on to the next interval, its end, so the second one, and we see that it ends at time 4. Once again, we will compare it to when the next interval starts, which is time 5. We see that this meeting ends before the next one begins, And so again, the person can attend both meetings. Now, the reason why we don't have to compare the first meeting to the last meeting is because we know already, if we have gotten to this last meeting, that the first meeting does not overlap with the second one. And so because we know that they are all sorted based on start time, and we know that the third interval starts after than the second interval, and the second interval begins after the first interval ends, then we do not need to compare the first and the third intervals directly. Now say we have this modified version of the intervals array where this last meeting starts at time 3 instead of time 5. And we see this change in our timeline. After sorting our array, we start again with the first interval, and we see that it ends at time 3, whereas the second meeting, the next meeting, starts at time 3, so they do not conflict. So we're okay up until this point. And we move on. Then we go and compare the ending of the second interval with the beginning of the third interval. But we see that the second meeting ends after the third meeting begins. So we have a conflict here. And because of this, we would stop our algorithm directly and return false. Now in our first case, however, we never reach a point where we find a conflict. Every preceding meeting ends before the next interval begins. And so when we reach a point where we get to the end of the third meeting, we have nothing left to compare it with. And so we are done with our algorithm. And if we ever reach this point with ever exiting with a false, then what we will do is simply return true. Now, in order to complete our algorithm, we know that we would just need to sort our intervals array based on start time. And we know that in order to achieve this, we would need to take up n log n time, if n is the number of intervals in our array. Furthermore, after having completed this sort, we need to traverse these intervals array in a linear time fashion. We go through each and every interval and compare it with the next one. And so in order to do this, it would take an additional linear time. And however, when we go and sum these, we know that overall our time complexity will be O of n log n. Now before going on to write our code, I wanted to mention that in addition to being an n log n time complexity algorithm, this algorithm we're using is constant in space, and this is because we are not using any additional data structures to store information. So what we said we wanted to do first in our algorithm is sort our intervals array based on start time. So we're going to pass in a key, and this key will be a lambda function, and for each interval we're going to sort based on the index 0, which contains our start time. Now we're going to go through our intervals array, which is now sorted. And what we want to do each time is check to make sure that each preceding interval does not end after the next interval begins. Because if it does end after the next interval begins, we have a conflict. And so we know that the person cannot reach both meetings, and we must return false. So we're going to say that if intervals at I, its end time, comes after the next interval begins, which is at index 0, then in that case we need to return false. Otherwise, we can continue on, and if we reach the end without ever returning false, we can return true. Now just one thing, we know that for the last interval, there will not be any subsequent interval to compare it to. So in our for loop, instead of going up until the last interval, we want to go to the second to last interval. So I'm going to add in a -1 there. Now let's make sure this runs. And I just missed an R here in writing intervals. There was a typo. And we see that it works. Thank you so much for watching this video. If you enjoyed it, please like it and subscribe to my channel. I'll see you on the next one.